Hello friends! In this lecture, you will learn about Nmap tools. We will cover each and every topic as much as possible, from basic to advanced. Let's move to the lecture. Nmap, short form of Network Mapper, is a free and open source utility for network exploration and security auditing. Many systems and network administrators also find it useful for tasks such as network inventory, managing service upgrade schedules, and monitoring host or service uptime. Nmap uses raw IP packets in different ways to determine what hosts are available on the network, what service is running on that host, what operating systems versions they are using, what type of packet, filters, or firewalls are in use, and dozens of other characteristics. It was designed to rapidly scan large networks, but works fine against single hosts. While Nmap is extremely powerful, it is also complex. More than 100 command line options add expressiveness for networking gurus, but can confuse for newcomers. I assume you know the basic familiarity with TCP/IP and networking concepts. This is a diagram of IP version for header. The first field tells us which IP version we are using. Only IP version 4 uses this header, so you will always find decimal value 4 is here. The next field is IHL, means Internet Header Length. This 4-bit field tells us the length of the IP header in 32-bit increments. The minimum length of an IP header is 20 bytes, so with 32-bit increments, you would see value of 5 here. The maximum value we can create with 4 bits is 15, so with 32-bit increments, that would be a header length of 60 bytes. Type of service, this is used for quality of service. There are 8 bits that we can use to mark the packet, which we can use to give the packet a certain treatment. Total length, this 16-bit field, indicates the entire size of the IP packet header and data in bytes. The minimum size is 20 bytes if you have no data, and the maximum size is 65,535 bytes. That's the highest value you can create with 16 bits. Identification. If the IP packet is fragmented, then each fragmented packet will use the same 16-bit identification number to identify to which IP packet they belong to. IP flags. These 3 bits are used for fragmentation. The first bit is always set to 0. The second bit is called the DF, means don't fragment bit, and indicates that this packet should not be fragmented. The third bit is called the MF, which means more fragments bit, and is set on all fragmented packets, except the last one. Fragment offset, this 13-bit field, specifies the position of the fragment in the original fragmented IP packet. Time to live. Every time an IP packet passes through a router, the time to live field is decremented by 1. Once it becomes 0, the router will drop the packet and sends an ICMP time exceeded message to the sender. The time to live field has 8 bits and is used to prevent packets from looping around forever. If you have a routing loop protocol, this 8-bit field tells us which protocol is encapsulated in the IP packet. For example, TCP has value 6 and UDP has value 17. Header checksum. This 16-bit field is used to store a checksum of the header. The receiver can use the checksum to check if there are any errors in the header. Source address. Here you will find the 32-bit source IP address of the sender. Destination IP address is 32-bit IP address of the receiver. IP option. This field is not used often, is optional, and has a variable length based on the options that were used. When you use this field, the value in the header length field will increase. An example of a possible option is source route, where the sender requests for a certain routing path. Here's a real-life example of an IP packet in Wireshark where you can see how these fields are used. I hope you got some idea about this. These kind of information very useful when we use Wireshark tool for capturing the data. Let's see some basic commands, which is so important. As I tell you before, that this course is basic to advanced. So, some advanced commands maybe you see in the start. I suggest you do not skip any part of this lecture. Let's open Linux machine and type very first command. First we will see the documentation about Nmap tool with the help of man command. This is whole list. If you want to complete documentation, here we are. No need to search other sources for help. Here, name and description of this tool. I suggest you to read whole documentation if you want to become an expert to use Nmap. If you don't know how to use these commands, this documentation will help you with example, like here you can see. Instead, you watch too many videos to learn about tools. I can say that official documentation will be enough. You can copy this documentation in single text file. I will show you later in this course. Here you can see firewall-related commands, output commands, target specification information, you can search for specific command. Just type / and then your command. You see, they give me information about related to search. And for quit the section, just type Q. Let's check the address of the network. This is my machine address, but we check the whole network. For that, instead 106, just type 1. With the help of this command, we gonna save whole interfaces which are connected to this network in text file. myinterfaces.txt is our file where we are saving our network interfaces. You can give any name you want to your file. Now, we are waiting till process done. Let's check the file. Here you can see, our file is here. Let's open it in a terminal. This is our data, which we collect through Nmap scanning. Here you can see IP addresses and open ports, state and services. This is my Metasploitable machine. You can see open ports. These all devices connected to particular address. Instead scan single IP, we scan whole network. In same time, we can easily guess which system ports can be exploited. Here is your file in File Manager. You can use it. While pen testing, we gonna need that kind of file. because when we work as a pentester in company, we will make a report and you can use it there. If someone give you a IP address in text file, you can directly scan that file. Let's see how. In this command, -T4, mean, adjusts timing to the aggressive level. -A, this shortcut option turns on advanced and aggressive features, such as operating system and service detection. -V, option in Nmap, increases the verbosity level and provides more details about the scan in progress. -PN, this option skips the host discovery stage altogether. Normally, Nmap uses this stage to determine active machines for heavier scanning and to measure the speed of the network. So this command disable host discovery. It will scan only port. This is range our port from 0 to 65,535, or you can specify any port you want. Just type here. Also, you can use IL for scan the targets from a file. Here, we will give IP list file we already have. This is our file. It will take some time. Wait for it. Also, you can use -ON instead of OL. Here is a result you can see. Let's make another output file for Metasploitable machine. We will put scanning result in this file. We use ON for normal output. And then create our new file and target IP. I think this is my Metasploitable machine IP. Let's check it. This is my file name and target IP. Let's open it in terminal. Can we get same result? It's done successfully. See, this is our result. As I told you before, that how to save Nmap documentation. Just type this command. You can give your file name you want. That's it. Let's check the file. Here we go. This is our documentation. Here you can see all necessary commands. Let's see the phases of Nmap scanning. One of the more crucial phases of ethical hacking is the scanning and enumeration. So, understanding the fingerprint of your target makes it easier for you to know exactly what forms of exploits or vulnerabilities could potentially be available to you. A great tool to get started with in this space is Nmap. The first phase is script pre-scanning is a phase in network scanning that uses scripts to gather more information about remote systems. This phase is not executed by default, but if you are looking to gain specific information about remote systems, you can use the Nmap scripting engine to accomplish this goal. Usually, you would use --script or -sv to indicate that you want to do this when writing your command. Second phase is target enumeration. In this phase, Nmap researches the host specifiers provided by the user, which may be a combination of host DNS names, IP addresses, and more. You can even use -ir to ask Nmap to choose your targets for you. Nmap resolves these specifiers into a list of IP version 4 or IP version 6 addresses for scanning. Third phase is host discovery, or ping scanning. Network scans usually begin by discovering which targets on the network are online, and thus worth deeper investigation. This process is called host discovery, or ping scanning. Nmap offers many host discovery techniques, like ranging from quick ARP requests to elaborate combinations of TCP, ICMP, and other types of probes. This phase is run by default, though you can skip it. Simply assume all target IPs are online using the -pn, mean no ping option. The fourth phase is reverse DNS resolution. Once Nmap has determined which hosts to scan, it looks up the reverse DNS names of all hosts found online by the ping scan. Sometimes a host's name provides clues to its function, and names make reports more readable than providing only IP numbers. This step may be skipped with -n, mean no resolution option, or expanded to cover all target IPs, even down ones with -r, which mean resolve all. Don't worry, we will use these all commands in this lecture. Just follow this course, step by step. Phase number 5 is port scanning. During this phase, probes are sent to see if a response is available to specific ports. Depending on the answer to those probes, the port will be determined as open, closed, or filtered. This phase is also done by default, but you can skip this phase if it does not fit in what you are looking for by using this option. Phase number 6, version detection. Let's assume that during the port scan, there were ports that were found to be in an open state. There is a possibility that further information can be found at that time. During the version detection phase, Nmap takes those ports and tries to determine what server software is running on that remote system. If you would like to run this phase during your Nmap scan, you would use this option. Number 7. OS detection. Each operating system can have a signature way of implementing network standards. This signature during the OS detection phase is used to potentially identify what operating system that host is potentially using. In order to run this phase, you will need to use this option. Phase number 8 is traceroute. Understanding the information of a specific host is just as important as is knowing the routes to that host. You can use the traceroute phase to see if routing information is available using DNS reverse lookup, again, for the host directly in question. You can use this by using this option. Phase number 9 is script scanning. During this Nmap phase, we'll be trying to do things like service vulnerabilities, collect more information from databases and other network services, and if possible, we'll try to gain more advanced version detection. All of this is done using the NSE, which mean Nmap scripting engine. This phase will not be executed unless you use this option. Phase number 10 is results. Once all of the previous phases have successfully executed with the options that you selected, it will then display the results of its findings. These results can be displayed either directly to the terminal or command line, or can be printed out to a file, if that is what you specified before running the results. Let's see. Nmap reverse DNS and traceroute scan against target.com. You can type same command with me. Traceroute option is used to trace the route a packet takes from the scanning machine to a target host. This can be useful for identifying routing hops, response delays, and points of failure. Run this command as a route. Instead, run this command again. Just type sudo with exclamation marks and hit enter. See, this sudo command automatically set before your command. Just hit enter. Here, in result, we have open ports and IP addresses on this target. Okay, let's find this address with the help of Whois tool. So, Whois is a network protocol and database that's used to query information about the ownership and registration of domain names, IP addresses, and autonomous systems. In result, you see, this tool gives us some more information like net name, country, organization, email, address, contact numbers, and etc. Nmap usually only performs intrusive scans on machines that are shown to be available during the ping scan stage. When this is done instead of doing full scans against every IP address, huge time and bandwidth savings are achieved. Sometimes you want to perform host discovery and nothing more, use SP command, while other times you want to scan every IP, use PN command. Sometimes you even want to print the target hosts and stop the process before sending any ping queries. Use SL command. So Nmap gives various high-level settings to control this behavior. First, let's see SL command without sending any packets to the target hosts. A list scan is a degenerate type of host discovery that just lists every host on the network or networks that are specified. Nmap continues to identify the hosts by default by using reverse DNS resolution. At its conclusion, Nmap also displays the total number of IP addresses to make sure you have the correct IP addresses for your targets. A list scan is a useful sanity check. In order to avoid scanning the wrong company's network, it is important to look into the hosts if they have domain names that you are unfamiliar with. Target IP ranges may be off for a variety of reasons. Pen testers have much more problems because even network administrators can type their own net blocks incorrectly. Security experts may receive incorrect addresses. In others, they use tools like routing tables and Whois databases to try to identify appropriate IP ranges. The organization may be lending intellectual property space to other organizations, or the databases may be outdated. Working with the customer before to determine whether to scan corporate parents, siblings, service suppliers, and affiliates is a crucial decision. So the initial list scan helps to confirm exactly what targets are being scanned. Stealth. is another justification for an advanced list scan. In certain situations, you don't want to start with a full-scale attack on the target network, because it can result in intrusive attention and IDS alarms. Although not discrete, a list scan provides information that could help determine which specific devices to target. It is possible, though highly unlikely, that the target will notice all of the reverse DNS requests. When that is a concern, you can bounce through anonymous recursive DNS servers using DNS server option. List scan is specified with SL command line option, since the idea is to simply print a list of target hosts. Options for higher level functionality, such as port scanning, OS detection, or ping scanning, cannot be combined with SL. Let's try a small practice with SL. List scan being used to enumerate the classless inter-domain routing network range surrounding the target.com. This option tells Nmap to only perform a ping scan, then print out the available hosts that responded to the scan. By default, the SP option sends a TCP and acknowledgement packet to port 80, along with an ICMP echo request. The SYN packet is sent using a TCP connect system call to port 80 of the target host. When a privileged user tries to scan targets on a local Ethernet network, ARP requests are used unless the IP option is specified. Remember, when strict firewalls are in place between the source host running Nmap and the target network, using those advanced techniques is recommended. Otherwise, hosts could be missed when the firewall drops probes or their responses. Another option is to skip the Nmap discovery stage altogether. Normally, Nmap uses this stage to determine active machines for heavier scanning. By default, Nmap only performs heavy probing, such as port scans, version detection, or OS detection against hosts that are found to be up. Disabling host discovery with the PN option causes Nmap to attempt the requested scanning functions against every target IP address specified. There are many reasons for disabling the Nmap ping tests. One of the most common is intrusive vulnerability assessments, but it is still possible that an active yet heavily firewalled machine might not reply to any of those probes. So to avoid missing anything, auditors frequently perform intense scans, such as for all 65,536 TCP ports against every IP on the target network. It may seem wasteful to send hundreds of thousands of packets to IP addresses that probably have no host listening, and it can slow scan times by an order of magnitude or more. Nmap must send retransmissions to every port, in case the original probe was dropped in transit. And Nmap must spend substantial time waiting for responses, because it has no round-trip time estimate for these non-responsive IP addresses. But serious penetration testers are willing to pay this price to avoid even a slight risk of missing active machines. Penetration tester can always do a quick scan as well, leaving the massive PN scan to run in the background while they work. TCP SYN. When IP address was registered to an active host was easy. Simply send ICMP echo request or ping packet and wait for a response. Firewalls rarely blocked these requests, and the vast majority of hosts obediently responded. Nmap offers a wide variety of host discovery techniques beyond the standard ICMP echo request. Note that if you specify any of the with P options, they replace the default discovery probes rather than adding to them. The TCP ACK ping is quite similar to the SYN ping. The difference, as you could likely guess, is that the TCP ACK flag is set instead of the SYN flag. Such an ACK packet purports to be acknowledging data over an established TCP connection, but no such connection exists. So remote hosts should always respond with a RST packet disclosing their existence in the process. The PA option uses the same default port, as the SYN probe can also take a list of destination ports in the same format. Another host discovery option is UDP ping, which sends an empty UDP packet to the given ports. The port list takes the same format as with the previously discussed like PS and PA options. If no ports are specified, the default is 31,338. A highly uncommon port is used by default, because sending to open ports is often undesirable for this particular scan type. When the UDP scan reaches a closed port on the target machine, it should return an ICMP port unreachable packet. This signifies to Nmap that the machine is up and available. Several other ICMP error types, such as TTL exceeded or host and network unreachables, are suggestive of a downtime or inaccessible host. If an open port is reached, most services simply ignore the empty packet and fail to return any response. This is why the default probe port is 31,338, which is highly unlikely to be in use. The primary advantage of this scan type is that it bypasses firewalls and filters that only screen TCP, ICMP ping. Nmap can send the standard packets sent by the ubiquitous ping program. Nmap sends an ICMP Type 8 echo request packet to the target IP addresses, expecting a Type 0 echo reply in return from available hosts. Many hosts and firewalls now block these packets rather than responding as required. ICMP-only scans are rarely reliable enough against unknown targets over the internet, but for system administrators monitoring an internal network, this can be a practical and efficient approach. Use PE option to enable this echo request behavior. While echo request is the standard ICMP ping query, Nmap does not stop there. The ICMP standard also specifies timestamp request, information request, and address mask request packets as codes 13, 15, and 17. Timestamp and address mask queries can be sent with the PP and PM options. Let me share you a list of ICMP types code. But before, let's revise ICMP with short introduction. ICMP stands for Internet Control Message Protocol. This operates at network layer. It is used for network diagnostic and control purposes. ICMP will not have any port number as such because it operates at network layer. The famous network protocol, which is ping, uses ICMP, and ping stands for Packet Internet Groper, basically used to test reachability of a host by sending an echo request and expects a reply back. ICMP header looks like this. ICMP header is super simple. 1 byte for type, 1 byte for code, 2 byte for checksum, and 4 bytes are unused, then follows the actual payload. ICMP messages can be simply classified into query messages and error reporting messages. For every message, there is a type and corresponding code. So, type tells us what is the type of message, and code breaks this further down to a clear message. Let's take an example. If type is system is shut down due to file system crash, it is really an elegant way to communicate queries and error report messages with just 2 bytes instead of wasting large space to transmit these messages. Now, let's see type, name, code, and also code description. Don't worry, we will cover ICMP in Wireshark course when we analyze the packets. Let's move to another technique, which is IP protocol ping. Host discovery sends IP packets with the specified protocol number set in their IP header. The protocol list takes the same format. If no protocols are specified, the default is to send multiple IP packets for these protocols. Using the same protocol as a probe, this host discovery method searches for responses. Alternatively, it checks for ICMP, protocol unreachable messages, which indicate that the destination host does not support the specified protocol. The target host is alive if either kind of answer is received. Another technique is ARP scan. One of the most common Nmap usage scenarios is to scan in local area network. On most local network, especially those who using private address ranges, which is granted by RFC, the vast majority of IP addresses are unused at any given time. When Nmap tries to send a raw IP packet, such as an ICMP echo request, the operating system must determine the destination hardware ARP address corresponding to the target IP, so that it can address the Ethernet frame properly. This requires it to issue a series of ARP requests. Let's see this in example. When a destination host is found to be unresponsive, the source host generally adds an incomplete intrib for the destination IP in its kernel ARP table. ARP table space is finite, and some operating systems react badly when it fills up. When Nmap is used in raw IP mode, Nmap sometimes has to wait several minutes for ARP cache entries to expire before it can continue with host discovery. ARP scanning resolves both problems by putting Nmap in control. Nmap issues the raw ARP requests and handles retransmission and timeout periods at its own discretion. The system ARP cache is bypassed. Not only is ARP scanning more efficient, it is also more accurate. Hosts frequently block IP-based ping packets, but they generally cannot block ARP requests or responses and still communicate on the network. Let's see some other flags which relate to ping scanning. Nmap usually only prints active and responsive hosts. Verbose mode causes Nmap to print down hosts as well as extra information about active ones. Setting a constant source port works for ping scanning, TCP, and UDP as it does with other Nmap features. Some naive firewall administrators make a rule set exception in order to keep DNS or FTP ports working. Of course, this opens a hole big enough to drive an Nmap ping scan through. N option disables all DNS resolution, while R option enables DNS queries for all hosts, even down ones. The default behavior is to limit DNS resolution to active hosts. These options are particularly important for ping scanning, because DNS resolution can greatly affect scan times. By default, Nmap will try to determine your DNS servers for DNS resolution from your resolve.config file in Unix system or the registry in Windows. Alternatively, you may use this option to specify alternate servers. This option is not honored if you are using system DNS or an IP version 6 scan. Using multiple DNS servers is often faster and more stealthy than querying just one. The best performance is often obtained by specifying all of the authoritative servers for the target IP space. This option adds length, random bytes of data to every packet and works with the TCP, UDP, and ICMP ping scan types in privileged users scanning. This helps make the scan less noticeable and more like the packets generated by the ubiquitous ping diagnostics program. Several intrusion detection systems, including Snort, have alerts for 0-byte ping packets. This option evades those alerts. An option value of 32 makes an echo request look more like it came from Windows, while 56 simulates the default Linux ping. TTL stands for time to live, which is a numerical value that indicates how long a packet should remain on a network or computer before being discarded. CAN timing options like T3, T4, T5, etc. These values speed up ping scanning, just as they speed other Nmap features, with a moderately fast and reliable connection between the source and target networks. So, the T4 option is recommended. These host input options are supported, as in the rest of Nmap. Users often combine the IL, which mean input from list, option with PN to avoid ping scanning hosts that are already known to be up. And the IR option chooses hosts at random from allocated Internet IP space. It takes as an argument the number of random hosts you wish to scan. Use 0 for a never-ending until you abort or kill the Nmap process scan. Output options. All of the Nmap output types like normal, grepable, and XML support ping scanning. Randomize hosts. Shuffling the host scan order with this option may make the scan less noticeable, though it also can make the scan output a bit more difficult to follow. The normal Nmap output indicates whether a host is up or not, but does not describe which discovery test the host responded to. For this information, we use the reason option. The results can be confusing for host discovery. Since Nmap does not always try every probe, it stops as soon as it gets a first response. So, Nmap might report an ICMP echo response from a host during the run, but then a RST response might be received first during a second run, and lead Nmap to report that. When you want even more details than reason command provides, use packet trace command. This option shows every packet sent and received by Nmap, including details such as sequence numbers, TTL, values, and TCP flags. D. Use for decoy, which is fully supported for privileged IP version 4 ping scans, it hiding the true attacker. It takes more than just being knowledgeable about all the possibilities covered in this and other sections to do effective scanning. You should know when and how to use them in accordance with the planned network structure and scanning objectives. As we know, before penetration testing, we will perform port scanning. So the question is, what exactly port is? A port in computing has three main uses, each as a type of receptacle in networking, computer hardware, and software. The first one is, a port in networking is a software-defined number related to a network protocol that receives or transmits communication for a certain service. Number 2, a port in computer hardware is a jack or socket that peripheral hardware plugs into. Number 3, a port in computer software is when a piece of software has been translated or converted to run on different hardware or operating system than it was originally designed for. A port, which ranges from 0 to 65,535, is a 16-bit that is used in computer networking to allow a computer to handle multiple incoming and outgoing requests using a single physical network connection. Some of these port numbers are specifically defined and always associated with a specific type of service. For example, file transfer protocol always port number is 21 and HTTP web traffic is always port 80. These are called well-known ports. Some of the common ports you can see here. Port numbers 0 to 1023 are referred to as system or well-known ports. The majority of users frequently use these ports. And from 1024 to 49,151 are called registered ports and can be registered with the Internet Assigned Numbers Authority for a specific use. From 49,152 to 65,535 are unassigned, can be used by any type of service, which are called dynamic ports, private ports, or ephemeral ports. If you want to search these all ports, go to official website. Like here, you can see. There is another site which is one of my favorite, which is Wikipedia. Click on this link. I like black screen, let me fix this. Perfect. In the sidebar, you can check your particular topic directly, or you can check whole page as you want. What we learned about previous lecture, about ports, here you can see ports and their description. You must check this out. These are well-known ports. Registered port, and also dynamic ports, you can see in this page. If you want to perform some activity on the network, you must understand the ports and protocols. This is mandatory. And for more information, you can check these links. This documentation will help you to learn about networking ports and related protocols. After understand the port, let's move on to another section, which is port scanning. The process of remotely testing many ports to determine their current state is known as port scanning. Generally speaking, the most interesting state is open, which denotes that an application is listening and taking connections on the port. Hackers frequently utilize a port scan to find weak spots or open doors in a network. Pentester can locate open ports and determine whether they are receiving or sending data by using a port scan attack. It can also show whether an organization uses firewalls or other active security equipment. Nmap is far more detailed than many port scanners, which have historically classified all ports as either open or closed. It creates 6 states out of ports. These states explain how Nmap perceives the port. They are not fundamental features of the port itself. As an example, while a simultaneous scan from across the internet using the same settings might show that port is filtered, or Nmap scan from the target's network may show the port as open. You can see port closed, filter, and open, while Nmap scanning. Let's define this shortly. As we know, we have 6 port states recognized by Nmap. Number 1, open, shows that a service is available on a specific port. Number 2, closed. It indicates that no service is listening on this specific port, although the port is accessible. It means that it is reachable and is not blocked by a firewall or other security programs. Number 4, filtered, which means that Nmap cannot determine if the port is open or closed because the port is not accessible. This state is usually due to a firewall preventing Nmap from reaching that port. Alternatively, the responses are blocked from reaching Nmap's host. Number 4, unfiltered. This means that Nmap cannot determine if the port is open or closed, although the port is accessible. This state is encountered when using an ACK scan. Number 5, open, filtered. This means that Nmap cannot determine whether the port is open or filtered. Number 6, close, filtered. This means that Nmap cannot decide whether a port is closed or filtered. Some are the port scanning method. We have TCP SYN Stealth. This is the most commonly used scan type due to its speed in scanning TCP ports. This scan is more stealthy than Connect scans and works on all TCP stacks. TCP Connect Scan uses the system call of the same name to scan machines rather than relying on raw packets, as most of the other methods do. It is usually used by unprivileged Unix users and against IP version 6 targets, because SYN Scan doesn't work in those cases. As you are doing a scan, don't forget to scan for UDP ports, because they also provide many security vulnerabilities. These special-purpose scans can bypass firewalls and access systems behind them. Unfortunately, they rely on target behavior that some systems, especially Windows variants, do not show. ACK scans are commonly used to map out firewall rule sets. This helps determine whether firewall rules are stateful or not. The downside is that it cannot distinguish between open and closed ports. Windows Scan is similar to ACK scan, but can differentiate between open and closed ports for specific machines. TCP Maimon Scan. This scan, obscure firewall evading scan type, is similar to the FIN scan, but it also includes the ACK flag. Although it can bypass more packet filtering firewalls, it only works on a smaller number of systems than FIN scan. TCP idle scan. This is the most stealthy of all scan types, and it can sometimes exploit trusted IP addresses. Unfortunately, it's also slow and complicated. Idle scan, as it has become known, enables completely blind port scanning. Attackers can scan a target without sending any packets to it. Protocol scan identifies which IP protocols. For example, TCP, ICMP, and IGMP are supported by the target machine. This is not a port scan, as it uses IP protocol numbers instead of TCP or UDP port numbers. However, it still selects protocol numbers using with -P option, reports results in the standard port table format, and uses the same scan engine as traditional port scanning methods. So it's close enough to a port scan to belong here. TCP FTP bounce. This deprecated scan type deceived FTP servers into performing port scans via proxy. Although most FTP servers have been patched to prevent this, it remains a useful method for bypassing firewalls. Let's see, how can we specify port for scanning? If you want, scan a single port, in this case port 22, by specifying just that number as the -P argument, as you can see. Or port names may be specified rather than numbers, but remember that a name may match multiple ports. If you want to scan multiple ports, and multiple ports may be separated with commas, remember that no protocol is specified, so these same port numbers will be used for whatever scan methods are specified on the command line. For example, if a TCP scan such as SYN scan is specified, so TCP ports 22, 25, and port 80 will be scanned. Those correspond to the services SSH, SMTP, and HTTP, respectively. If a UDP scan is selected, those three UDP ports will be scanned. If TCP and UDP both are specified, those three ports are scanned. For each protocol, total 6 ports will be scanned. Port ranges may be defined by separating the beginning and ending ports with a hyphen. To provide multiple ranges or particular ports, use commas. This option searches many ports, including 80, 81, 82, 83, 84, 85, 443, and 8000. Based on the port numbers, this person is presumably scanning TCP for web servers. Omit beginning and end numbers to scan the whole range, excluding 0. Wildcards may be used to match ports with similar names. The best Nmap output settings for port scans. Increases Nmap's verbosity, forcing it to publish more information about the scan in process. Nmap displays open ports and provides completion time estimates for scans that may take longer than expected. Use it twice or more for increased verbosity. -D increases the debugging level, causing Nmap to print out details about its operation that can be useful for tracking down bugs or simply understanding how it works. Higher levels result in massive amounts of data. Packet trace causes Nmap to publish a summary of each packet transmitted or received. This feature is useful for both troubleshooting and educating new users on Nmap's internal operations. To prevent publishing thousands of lines, restrict the number of ports being scanned. This format is similar to the normal interactive output given by Nmap during execution. The -OX switch generates XML output, a tree-structured file format that can be used to export or write scan results. XML output is a desirable format because software can easily parse it, and XML parsing tools are available for all computer languages. Save output in Nmap's greppable format to specific file. This tabular style displays each host's output on a single line, making it simple to search for open ports, operating systems, program names, and other relevant information. To store scan results in normal XML and greppable formats at once, you can use this option. Nmap will append scan results to specified output files rather than overwriting them. Only open ports are shown in Nmap's interesting port tables.